Welcome to another quick bite video from Insurance Domain Training Center. Although drone-based property inspections have been used by insurers for several years, the combination of drones, thermal imaging, and artificial intelligence is transforming the way risks are evaluated. In this video, we'll see why this powerful combination is particularly valuable for inspecting large factories and commercial facilities, and how it enables underwriters to make faster, more informed decisions while helping prevent losses before they occur. Let's dive in.
For decades, commercial property underwriting relied on a very physical, manual process. To understand the risks of a massive factory or a sprawling warehouse, carriers sent out an engineer with a clipboard and a ladder. This method has three vulnerabilities. It takes days or weeks to physically walk these enormous sites. It forces workers into dangerous, precarious environments. And the resulting data is largely subjective, dependent on what one person happens to notice or miss during their walkthrough. Missing a single hidden defect can be financially devastating. In 2017, a fire broke out in a tunnel beneath Atlanta's Hartsfield-Jackson Airport. The cause was traced back to a single loose connection in a piece of electrical switchgear. When that faulty connection finally ignited, it crippled both the airport's main power system and its backup. Delta Airlines alone canceled over 1,400 flights, resulting in an estimated $50 million in lost revenue. The shift toward a new standard began in August 2016, when the FAA implemented its Part 107 regulations. This rule change removed the requirement for a commercial drone operator to hold a traditional pilot's license, significantly lowering the overhead for aerial data collection. Insurance carriers realized they could stop relying on a human climbing a ladder to estimate a building's condition. They could instead deploy agile aerial sensor platforms to capture the objective truth of a property. The first layer of drone capability is the macro scale. In the North American market, this is used to assess massive, flat-roofed commercial complexes like warehouses and retail centers. By flying over these massive structures, drones establish a highly accurate, verifiable baseline of the property's condition before the insurance policy is even signed. This raw imagery is fed into artificial intelligence models trained to classify up to 20 specific defect types, like spalling, corrosion, or hairline cracks. The AI isolates these anomalies and tags each one with precise GPS coordinates. This macro-level analysis removes human estimation from the risk-rating process. When a severe storm eventually hits, carriers have a documented record of the building's original state, protecting them from fraudulent claims over pre-existing damage. Visual data only tells part of the story. By swapping standard cameras for infrared or IR thermography sensors, drones can map heat signatures that are invisible to the naked eye. This thermal scan of an electrical panel shows how contactless sensors scan switchgear operating under full load, pinpointing overloaded circuits as bright, glowing hotspots. Identifying these anomalies allows engineers to order repairs before friction sparks a fire, preventing catastrophic damage and long business interruption. Underwriters also use these thermal sensors to detect hidden structural deterioration, relying on a concept called the thermal mass principle. When water penetrates a flat roof, the trapped moisture soaks into the insulation. During the day, that pocket of water absorbs heat from the sun. After sunset, dry roofing materials cool down quickly, but the trapped water holds on to that solar heat much longer. When a drone flies over the facility at night, those hidden, rotting leaks glow brightly against the dark, cool background of the healthy roof. It exposes multi-million-dollar liabilities hiding right beneath the surface. In Europe, the underwriting market faces a different challenge. Here, risk engineers specialize in assessing complex, heavy industrial factories, characterized by intricate pipe networks and massive high-temperature assets. To inspect these confined spaces, engineers deploy specialized collision-proof drones directly inside active boilers, storage tanks, and vertical plant shafts. Because these drones are encased in protective cages, they can safely bump along walls and navigate tight industrial corridors to generate complete 3D digital twins of the internal layout, all without requiring the factory to halt its daily operations. Underwriters gain absolute spatial awareness of a facility's most volatile components and they gather this data without ever sending a human worker into a hazardous confined space. Integrating aerial mobility, thermal sensors, and AI processing shifts the underwriter's workflow toward a high-speed, automated process. Automating data collection and utilizing machine learning analysis increases a risk engineering team's review capacity by up to 400%. This added capacity decreases speed to quote times, freeing engineers from manual gathering to act as high-level risk advisors. Instead of relying on memory or handwritten notes, carriers and policyholders now share an undeniable GPS-stamped visual record of the property's condition, eliminating costly disputes over damage claims. Aerial robotics allow the insurance industry to identify specific thermal sparks, providing the data needed to prevent fires before they ever start.
Thank you for watching the Quick Bite series from www.insurtech.com. Please like and subscribe to our videos for you to get notification when we upload new videos.